Hello, everyone. I'm Stephen Hardy, Editorial Director and Associate Publisher of Broadband Technology Report, and it's my pleasure to welcome you to today's webcam-enabled webcast, New Approaches to Service Activation and Maintenance, Your Questions Answered. Our webinar today is sponsored by Bialy Solutions, whom we thank for their help in making today's event possible. So the effects of COVID-19 have been felt across the community, most obviously in the spike in bandwidth demand worldwide. It's also created an environment in which the normal ways of exchanging information about how to handle such spikes and keep the network running smoothly have been hampered as well. That includes things such as canceled trade shows. For example, ANGACOM was supposed to have held this month, but has been canceled for the year. That also includes face-to-face meetings with your coworkers, peers, and suppliers. So to help with that, today we're going to attempt to fill the gap with the help of the folks from Bialy. I'll be talking today with the gentleman whose faces appear below, but who's you might be able to see a little bit better in this slide. They include Koji Akamoto, who is the Senior Director of the Multi-Access Connectivity Business Unit for Bialy Solutions. Koji leads the access field instruments and cable systems business at the company. With the help of the knowledge gained by more than 18 years of experience, Koji collaborates with global service providers and MSOs to help them navigate through technology and industry transitions. You'll also hear from Dave Herring, Senior Product Line Manager at Bialy. Dave manages Bialy's systems products used to monitor and maintain HFC plants worldwide. Having joined Bialy in 2006, Dave leverages more than 20 years of test and measurement experience to help deliver solutions to MSOs that enable them to transition to new technologies like DOCSIS 3.1 and Remote PHY. And last but not least, I'll talk to Rob Flask, Head of Product Line Management, Cable and Access for Bialy. Rob is a 25-year veteran of the communications test industry. He leads the cable and access instrument solutions business within Bialy Solutions and has responsibility for P&L and overall roadmap and strategy. His focus has been working with operators around the world to successfully transition to gigabit broadband and DOCSIS 3.1. And with that, let's begin. I'll start with a question for Koji Akamoto, who, as I mentioned, is the Senior Director of the Multi-Access Connectivity Business Unit for Bialy. Koji, obviously, many of us are working from home and staying at home as a result of the COVID-19 pandemic. What challenges has this posed for network operators, and what is Bialy doing to help them overcome them?
What I'm hearing in the last, let's say, couple months, talking to different operators, they're facing quite a bit of changes, and I'm not sure if this is really a short-term thing. A lot of people kind of talking about this may be very short-term, but I think a lot of operators almost treating this as a kind of more than normal, thing that's going to go on for several months or maybe even a year or over. So what we have seen, obviously, I think you're both feeling this, is that operators trying to reduce the amount of time that the technicians spend physically, with the end customer. So that could be related to the new installs. Sometimes you hear the phrases like at zero touch. That means you leave stuff on the front door. Once it's ready, everything is verified, and then customer do more installation themselves through some of the innovative tools or videos and so on. And also, if there is a problem, they're trying to figure out how they can minimize that. And we talk about those couple points later, I think, with the panels and the discussion points here, that how we think we can help out in those areas. The other things that just from the consumer behavior wise, the big change is it used to be the internet was consumed more often or not at night. Like we go home and we spend it. The kids come home from school and so on. But that's kind of shifting since we're all working like this. We are all of us at home. The peak hours are really now no longer just at night. Actually, it's pretty consistent from the middle of the day all the way through the day. So with that, one of the key takeaway from the talking to top customers and operators around the world is the upstream is getting the most hit, basically. You see a significant increase in overall traffic when the access part of the network. When I say access part, it's a hub site, CMTS down to the home portion. And we're seeing more on the upstream side. So, and that will create challenges on the cable network in general, because it's not really a symmetrical network. So what we have seen is definitely an incremental work to improve the upstream capacity. There are multiple methods to accommodate to solve the same problem based upon the operator's current network, as well as the architecture and where they want to see in the future. But in general, there are few kind of trends. Some operators they are deciding to do no split, incremental no split. We're seeing some places as much as 100% increase versus the original budget they have. But clearly seeing that, and some people are talking about maybe faster DAA rollout. The same thing, except it's just different type of nodes, basically. Some talking about the more turning on the 3.1 capabilities and putting the OFDMA in the, let's say, traditionally tough band to put single carrier QAM, which is typically below 25 megahertz, and OFDMA is a little bit better at coping with that. So we've seen that type of things. And also frequency extension upstream is also being discussed around the world, and we see more and more customer talking about 85 and even 204 to get closer to symmetrical service that they could offer on the cable network. But also, most importantly, that we are using these, like we are doing this webcast. It'd be kind of embarrassing when I'm talking to you and all of a sudden the video get cut or voice get cut and can't see everybody's reactions and faces and no longer communicate. So this quality focus, it's no longer, let's say, entertainment usage for the internet anymore. It's really a utility. And it's a very important utility for people to stay connected, to actually work. Or some people may be taking classes, so it's good for the students. And so it's becoming like a lifeblood of everybody, just like power and water and storage. So the focus of the qualities hasn't gone up significantly as well because of this. So I see more focus in this area, and which we'll talk about how we are kind of working and collaborating with the operator in this space. Lastly, I'll say we also talking with the customer about the core part of the network. We got the CMTS down to the home, and then there's the one behind the CMTS. And it seems to me, at least talking to initial phase, this capacity increase is mostly affecting the access part of the network. It doesn't mean that we should not be watching out for the backbone side, because if that gets, has the capacity limited, then obviously has end-to-end effect to the end customer quality. So, but something that operators definitely watching, making sure the bottleneck isn't going to be just one section of the network.
Thank you, Koji. So let's dig a little deeper into some of these issues. I'll start with Dave Herring, Senior Product Line Manager at Bialy. Dave, Koji mentioned the increased focus on quality and the importance of reliable services for working from home and e-learning. How is Bialy helping with this?
Really, as we go through and we talk to operators worldwide, operators have a variety of systems that will tell them where they need to go through and make improvements to their plant so that they conform to engineering standards. You see many virtual and physical data sources available, from the modems and the CMTSs to test equipment, such as return path monitoring, as well as the field instruments that technicians use. And they have processes built around the various systems that they have to allow them to monitor, take that data, correlate it to figure out really what alarms should be raised, how to prioritize them, and how to optimize both the response that they're making in terms of plant maintenance or home repairs, as well as optimizing the network. Everybody's trying to squeeze more capacity out of the network because it's so difficult to go through and make changes that are unplanned, and ultimately to resolve the issue and verify the issue is resolved. So when we talk to operators, it's not just a discussion of how can I improve this tool or that tool. It's much more effective when we have customer engagements where we go through and we understand really how are their processes driving the increase in quality of the network, okay, versus the increase, for example, in how well it's going to be relative to engineering standards. So the first tenet of this is making sure that the systems being used are subscriber-centric. So very often we see there's just once again, many systems that operators would use that would generate data where the network is non-conformant to engineering standards, or things like the average MER, for example, is falling below standards. But when you look at it, it's really all about what the subscriber view is. So if I have, an average of, 5% code word errors over the, just a small part of the day, that may impact a few subscribers worse than others. But if that 5% is concentrated on a third of the subscribers on the node, they're going to be out of service. So it's really all about going through and truly understanding when and to what degree the subscribers are being impacted. Okay. Then the next tenet would be dispatch to fix. So I have systems that tell me where I need to go, but which problems in the network are really the ones that are causing my subscribers to notice a degradation in quality? I mean, I've personally experienced, I suspect we all have issues from time to time, my modem's resetting, things like that. Those are the problems that we really need to go through and resolve, and we need to know exactly what problem to go through and fix. Is it a home problem? Is it a plant problem? Is it a back-end problem where for example, I just don't have the capacity that I need, so I can't fulfill my station maintenance requests? And then the third aspect to look at is just integrated resolution. So I have lots of tools. Do the technicians have the visibility they need in the field to those tools to ensure that when they feel that the problem has been resolved, the problem truly is resolved, and it wasn't just a transient problem that went away and they're going to have to come back and roll a truck to fix those again. So if we break that down a little bit more, let's talk about identifying at-risk subscribers. So just very simply, when you're going to roll a truck, you roll a truck to a hub site, you roll a truck to the plant, you roll a truck to the home. Okay, but it's going to be node-based, essentially. So really understanding what nodes have the biggest subscriber impact is the most important foundation piece. So that way I have my truck and my maintenance crew in the right place. The next problem that I want to look at is if the problem has persisted for a long period of time, that's much more noticeable to the customer. It's much more noticeable. The subscriber is much more likely to churn. So taking into account the chronic problems is also very important. And then the last part of it is understanding small pockets of issues. So if I look and I see that I have a bunch of yellow modems there, or you see there's an alignment alarm, if that's a poor quality, for example, if I'm just seeing poor QoE in that area, that's a neighborhood. Those are customers that live very close to one another. They talk. And our customers absolutely tell us that neighborhood churn is a phenomenon they experience. And they'll see that churn in pockets, and it's because of an aspect like this. So you need to be able to go through and get visibility to, I do have a concentrated issue. It may only affect 10% of the subscribers on the node, but they're all really close to one another. It's a neighborhood. I need to go through and get that neighborhood up and running again to maintain my good standing with the customers. The next piece of it is the holy grail. I want to dispatch to fix, not to find the problem. I don't want to go into the field and troubleshoot. So the first thing I need to know very simply, is a problem localized or is it impacting the whole node? So you can see, on the map here, I have a segment which is problematic. The next issue I'd want to know is it an upstream or a downstream issue? Really, what problem am I looking for when I go into the field? And there's actually a third aspect to that. It could be a stability issue. So a stability issue, for example, is I have modems that are resetting a lot. So that's very noticeable to customers. It's disruptive to their service. The system seems glitchy to them as they're trying to do a video conference like this. You get video and audio drops and things like that. I need to understand when the problem occurs. Many problems are transient. And if I send a technician to the field at the wrong time, he shows up, he's going to do something, and say the problem's fixed and go away. But it's a transient problem, and it's going to come back very predictably at a preset period of time. So we see numerous examples of that. The next one is, okay, so really what is the physical impairment? Is it related to noise? So in the example you're looking at, you can see that when the quality was high, I don't have noise alarms. When the quality is low, I do have noise alarms. Well, this is a good example of I have a noise issue on this node. I need to understand, is it an impairment in the outside plant? So is there a common point? Is there a tap? Is there a splitter? Is there an active, like an amplifier, that's a common element to the problems that I'm seeing? Is it a home issue? So when a customer calls, I need to know, do I dispatch to the field? Do I dispatch to the home? And so many times when customers talk about going through and making improvements, it's these sort of double dispatches that they're trying to fix, where they send a technician to the wrong place, the problem reoccurs, so it makes the customer very unhappy. Once again, drives issues like churn. And then you get into things like overutilization. So if, for example, I have a bunch of noise, my upstream QAMs can go from 64 QAM to 16 QAM, and all of a sudden, all my lights turn green because my MER is great for 16 QAM, but my capacity is too low to support all of the acknowledgement. So when you see the HTTP traffic, I need to be able to go through and acknowledge all these packets. So the demand on the upstream is very high. When you have no more mini slots available to transmit on the upstream, you start seeing things that, look like stability issues and modem resets and things like that going on. But there could also be other things. Do I have a fiber break or a degraded fiber that's associated with the hub or with the access network that this node's attached to? Do I have a technician working on the node? So clearly, if I have a tech out there and he's going through and he's making repairs in the middle of the day, that's going to cause me service problems. So let's make sure that we're not chasing a ghost if we're actually looking at one of our own technicians out in the field doing repairs. So those are all examples of smart dispatch. And then, integrating and providing consistency to the find and fix process is all about, once again, getting that customer-centric approach so that you can do pre-dispatch analysis and figure out, these are the sorts of problems that I want to go through and chase that's really going to move the needle in terms of my customer quality. And, I have different tools looking at downstream, upstream to help me go through and localize the problem. And then the technicians out in the field, he has tools like leakage, which point him to HFC impairments, ingress suppression, so just going through and chasing noise on the upstream. And as you start to move to remote PHY, you see that there's a coupling between the systems used for communicating with the CMTSs and the remote PHY devices and this sort of plant maintenance. So providing that sort of connectivity is really essential as we go through into transition to new technologies like remote PHY. So having that technician in the field with access to these tools so he can verify, based on the tools that's showing me the quality of my customers, have I really fixed the problem, is critical. So what Viavi's done is we've developed a system called ExpertTrack, which really is intended to address these problems head on. So this is not about turning lights green. Okay, red light, green light. It's about resolving the problems that matter the most to the customers, to the operator's customers, to prevent churn. So we look at the different probes and instruments that we have, okay, for return path monitoring, for leakage, for fiber monitoring. As we go through an interface, with our StrataSync product, which takes information from all field instruments, we look at everything from Ethernet test to fiber optics to RF test. And we put that together with virtualized data sources to provide visibility on any sort of device. So whether it's a computer screen in a NOC or in somebody's office, or it's a tablet or a smartphone in the field, or whether it's an instrument, provide that sort of connectivity and take data in and out because, the operator has access to other data sources, trouble tickets, churn rate, things like that, which need to go through and be integrated. So this is really how we deliver on identifying the at-risk subscribers, okay? Really focus on customer-centric issues and prioritize repairs based on what the service impact would be. Dispatch to fix, not to find. So we talked about going, to the right place at the right time with the right instrument. Okay, that's what smart dispatch is all about. But another aspect of it is eliminate unneeded maintenance. If I don't need to go through and sweep, don't sweep. If I don't need to align, you don't need to go through and do alignment. But if all my lights are green because I've downshifted on the upstream once again, I've not optimized my existing infrastructure. I need to be mindful of that and understand when those sorts of issues are going to cause me quality problems from the subscriber's point of view. And then really integrate all that in with a find and fix process. So having the consistency across the different architectures and vendors. And as operators, roll new technologies like DOCSIS 3.1 and DAA, they can't completely retrain the field crews. They need, some level of consistency on the sorts of tests that are done for turn up and, new installations and things like that. So providing all that integration is key. So as you can see, Viavi's been working very hard at going through and helping customers move the needle on their customer quality.
Great, thanks, Dave. Now let's look at some of the practical issues the current environment poses for network technicians with Rob Flask, who, as you'll recall, is head of product line management, cable and access for Viavi. Rob, repeat visits to resolve network issues are always undesirable, but today repeat visits could raise health issues for technicians and subscribers in addition to the usual concerns about cost and customer satisfaction. What can you suggest that would help minimize the need for repeat visits?
So minimizing that contact is a big ask, right? So you can have the fewest number of technicians and the fewest number of visits to minimize that risk. One of the things we have to help technicians and operators is the ability to remote control and view a field meter. So if you look at the example here, you could have a technician who's trying to test outside the home. He's finding problems where he needs to, I'll say, phone an expert, phone home. He can have someone remotely look at the test device and see the results and help do coaching, fix the problem while they're there. So they can do this remotely through either a PC, a phone, a tablet. Don't need IT involvement, and it can work through firewalls, so they can make sure that they fix the problem while they're there on the first visit, and then make sure that every visit counts. So their time is precious, and those visits are want to minimize those. The other benefit of that feature of Smart Access Anywhere that the technician can do to minimize his exposure and limit it is he could actually go inside the home if necessary. If he's done outside work and figure out he has to be inside the home and test at the CPE location or the where they were going to put the gateway, for example, he can remotely control it. So he could go inside with his mask, install the meter, go outside, remotely control from the safety and comfort of his either vehicle or just sit outside and see what's happening and troubleshoot problems. And we're seeing operators use other tools alongside of this type of technology, so they can remotely talk to the customer. So we've got operators using, one example, there's multiples of these tools out there, but like TechC, so they can have a video chat with the customer live, and if they have to have them, reconnect, go tighten a connection, move a modem, do something, they can do that and instruct them through their phone, and then they can use the the Viavi devices to make sure that they're fix the problem without being side by side with the customer. So to make that minimize that time and testing inside the home and make sure you get consistent results, make sure you have the best quality to get the success rates up and the consistency, is having some type of automated and consistent test process automation tool, right? Give them the ability to prevent the errors so the technician does it right. Make sure if they're in this times people are getting reassigned and reallocated and don't get the one-on-one on-hands testing and training time sometimes because they're remote, they can't go sit in the office and work. So reduce the training, so give them that process. It'll step to an automated sequence of events and give them the consistency that they can help reduce the times, reduce the repeats, improve the quality, reduce the training, and overall reduce the costs for the operators. An example of an automated process I'll talk to here, Stephen, is like certifying the drop in the home, right? So making sure that the process that you have, so test at the incoming service, make sure the network's good, right? Because if the network's not good, you're going to have to get online and help get your network engineers to either fix the problem before you leave or identify if it needs escalation. But if you don't have good service coming in, there's nothing it's going to be able to do from there. Big portion is then validating at the point of entry. This is the control part you have of making sure it's good from what the service came in into the side of the home without going in the house, right? Make sure you have good gigabit services. A couple of things that'll also help escalate if they want to make sure the service is ready for self-install later or increase their bandwidth. So someone might have signed up for the lowest tier, even for that day, but as they start doing more video conferences, remote learning, so, I want to go to the 500 megabit down and the 40 megabit up, you can make sure that service is going to be ready to work. Okay. With that, again, to make sure you reduce the repeats, is make sure the drop integrity is good, because that is a portion that no matter what you have, the operators have control over. Make sure that you do a test to make sure if you have any faults in the drop that would cause a future problem, or have someone have to come out and have another visit to do a drop replacement. So if you, before you call another crew in to send 2 guys out to the house, eliminate the drop replacements by making sure your drop is good, and then eliminate the escalations by having that process to make sure that it was good at the home, good at the tap, and eliminate yet another visit by another technician to that same premise. So one thing we've had, and we've talked with a bunch of operators and done some studies on, is to try to reduce the amount of time troubleshooting and fixing it. What we call HL ingress scan, or high-level ingress, where it puts a very strong signal in to then validate both the drop portion as well as the home. It'll identify weak points, find problems faster, and potentially without going in the home. So by doing that high-level scan, you can make sure that's good from the tap to the drop, and actually can also, if the problems are big enough, he can pick this up depending on the home style and what it's designed. Problems inside the home without going in, because he can pick up if there's a leak, something he has to go in and do something where we had showed earlier, like the Smart Access Anywhere. Go find errant connections, unterminated connections that he could have have someone go in and do a termination or make sure the equipment's connected properly. So isolates those problems, finds any of the faults with less time, and the studies have shown that this can actually reduce their time by over 15 minutes compared to doing hunt and replace and normal type of signal level, just hunting to try to find problems. So that reduces his time inside the home and the exposure to that. This also then is giving proven numbers to reduce those repeat trouble calls. So again, get one technician, get the job right, and don't have to send back another technician to the same house.
So, Rob, one of the things you mentioned is people getting reassigned. In that context, we know many operators are doing what they can to keep as many employees on the payroll as possible, so reassignment might be part of that. How is this affecting what's going on in the field, particularly in terms of what technicians are being asked to do?
As we talked earlier about test process automation and the benefits of what that does, one of the key values of that is being able to, like I said, mention dynamic resources. Let them do different jobs that they're not familiar with, so they can either work on improving network quality, doing different services where they have less contact and touch, so they don't have to, furlough their employees. They can use them and do other stuff, so they can keep their commitment to their employees to keep them active, and then they can help work on things of improving plant quality. One example here I'll just show is of having an automated test process in something that works with your either your instruments or your smart devices. If you had we're getting more and more prevalence of technicians getting involved in dual technologies. So it can be DOCSIS 3.1, it can be PON to get the DOCSIS 3.1 to the side of the house, or even fiber to the home. So having a tool and a process allows him to easily learn, adapt, and do a one-button test so something he's not familiar with. So in this example, he's doing a fiber inspection and an OTDR trace with easy troubleshooting instead of having to read an OTDR trace. He could, one day have been doing DOCSIS 3.1 and easily go to the process of doing a fiber install, a PON install, where he might not have to even go into the premise because he can do it and activate it in his Wi-Fi, for example, for the technician to not even have to go in the home. So the other part I think is very prevalent is activity towards making sure you have the outside plant working as good as possible, so you can improve the service quality and the reliability. And there's been a big uptick in what I'll say is drive-out leakage. So the ability to drive around, find service impacting problems. So anyone with a truck or equipment can drive around, figure out if there's outside plant problems that Dave was mentioning earlier that could cause issues, and locate them, find them and fix them while he's out there doing the drive out to improve the overall quality of the network. So a lot of this, we've seen operators trying to get the capacity so we can get this upstream. It went from a heavily downstream focused world to now everyone's trying to get as much capacity upstream as possible. So working on accelerating frequency extensions compared to where they were, rapidly turning up OFDM-A to get additional capacity and additional efficiency, where there was a little slow push before. So OFDM-A has become a bigger push for the operators to get that extra upstream kick that they can do and leverage that DOCSIS 3.1 investment that they've put into their plants. Part of that is then, making sure you can do the leakage and adapt to those frequency changes. So as you move your plant, how you do your leakage, it changes, so you can fit in where those new downstream OFDM carriers are, do extensions to go up to different frequencies, for example. End goal, they're having technicians do other tests to make sure they improve the network quality instead of having to keep them off of work.
So one of the things that both you and Koji mentioned is operators looking to add capacity to their networks, particularly in the upstream, as subscribers have increased their usage of such services as two-way video, or they're doing multiplayer gaming or something like that. How is Bialy helping operators with these rollouts and the associated maintenance to alleviate the sort of bandwidth concern?
Yeah, so instead of, on top of doing just ride-out leakage, making sure that upstream is working better to make sure that capacity is upstream capacity is getting the maximum out of it. We have a lot of specific operators reallocating their fulfillment guys, like, hey, let's give them a tool to go do ingress mitigation. So as we find these problems, they can go out and search and make sure that they can clean up the plant, so they can turn on OFDM-A, fill in that extra capacity, make sure they reduce the number of retries so their capacity is better. Mentioned before about turning up OFDM-A services, so they can do that and then coexist, fit in any of that spectrum that they weren't using before with OFDM-A, going to frequency extensions, 110 megahertz, 204 megahertz, and then making sure you have that as you turn up those services, make sure you get the capacity. So, example here, we're getting 2 gig down and 700 megabit maximum usage of that pipe. So your plant is good. That it's going to be good for the services when they do future upgrades.
So there are a couple of additional things that we do want to think of. I mean, DOCSIS 3.1 is very important. We want to make sure it's operating, but one of the fundamental things we talked about is you have an existing plan, it has upstream SC QAMs. Let's just make sure they're all running at the modulation that you think that they're running. Because if I have a bunch of noise or stuck outs, things that are causing my upstream QAMs to go from 64 to 16 QAM, then my capacity is automatically reduced, and it just can't carry the demand of having to take care of all those HTTP acknowledgments. DOCSIS 3.1 is the silver bullet that a lot of operators are looking at to go through and make sure that they can, take advantage of every scrap of that upstream, because OFDM-A will run in some of the dirtier places of the upstream that you really wouldn't want to put in an SC QAM. So providing that sort of consistency and visibility of OFDM and OFDMA is really key to making sure that you can provide the additional bandwidth. So there are some additional considerations for DOCSIS 3.1. I mean, you have the PLC and things like that you need to worry about. But by and large, you can go through and look at the health of the individual subscribers and make sure that you don't have pockets of issues, things like that. But the added complication that we get with DOCSIS 3.1 is what profile it's using on the downstream, IUCs on the upstream. If everybody is running essentially at the lowest modulations, the lights are all green. I don't have code word errors, uncorrectable code word errors and things like that, but I don't have the capacity that I need. So just providing, the sort of tools that provide at a glance information. I look at this node and I can see how many modems are actually capable of operating at the higher profiles. And if that starts to shift too far down, and I only have 10% of my modems that can take advantage of the top 2 profiles, I need to go through and optimize my plant, upstream or downstream, depending on where the issue is, to go through and correct that problem. So that's a big change with OFDM and OFDMA that we see. As you start to cram all these carriers in with OFDMA, new tools on the upstream like Heatmap, just to go through and more clearly see wide ingress. I can see impulse noise rippling across the carriers. That's a big issue. Okay. So providing more visibility under the carriers on the upstream for OFDMA is what Heatmap does, and then providing the sort of additional troubleshooting that we get out of the DOCSIS 3.1 standards, basically. So one of the biggest ones when I look at the DOCSIS 3.1 analyzer is being able to go through and see essentially MER per subcarrier, which is ingress under the carrier. And that way I can see really what is happening. So although my overall code word error rate may be manageable, if I can see that I have an area that I really need to go through and clean up so that things can run at higher modulations, that's sort of visibility that these tools provide you to make sure that as you're rolling this out, you start with the sort of capacity gains that you're looking for and you maintain those sorts of capacity gains. So those are some of the things that we're seeing on just expanding the bandwidth, especially on the upstream.
And with that, we've come to the end of our program today. If we didn't get a chance to answer your question just now, or you want to ask one offline, perhaps you're watching this on demand, you can reach our speakers via the email addresses that you should see here on your screen. Finally, I'd like to thank Koji, Dave, and Rob for sharing their expertise, Bialy Solutions for the help in making today's event possible,